All right, we've done alcohol synthesis, alcohol synthesis, ether synthesis. Now we're on to epoxides. And the situation is that if you take this molecule, which is called a halohydrin, why is that? It has a halogen, halo, and it has an alcohol, and hydrate is drinking water, you're hydrating. So this alcohol is the hydrin part. OH is very similar to water. So this is a halohydrin, and essentially in Chapter 10 you're going to learn ways of synthesizing halohydrins, but right now we are learning how to change a halohydrin into an epoxide. And all you need to do is treat that halohydrin with a strong base such as sodium hydride. So you guys have all the tools, you know what these things do already. What I want you to do right now is pause the video and write out a mechanism for how this reaction occurs. It's essentially 2 steps. Okay, you've done that. So essentially what's going to happen here? Well, we have a really strong base, sodium hydride. Remember that sodium plus, H minus. So what do strong bases do? They deprotonate things. This alcohol is relatively basic. It has pKa of what? Yep, 16. So that, as far as the mechanism of this first step, is just deprotonating that OH, which provides us with this alkoxide intermediate. So this step 1 was just an acid-base reaction. Why does it go forward? If you're still confused about that, remember our pK discussion we had during the ether video? It's the exact same situation. This is really a downhill reaction because this is a much stronger acid than H2 is. Also, H2 is a gas, so as soon as it forms, it's like it just bubbles away. Pretty fun noise I made right there. So now we have our alkoxide, which is a strong nucleophile. We have our bromide. How does the next step occur? Well, it's just going to be a substitution. The only thing that's kind of new here is it's intramolecular. This oxygen is actually in very high concentration because it's literally being held right next to that leaving group. So it will come down and kick out that bromide. So it's making a new carbon-oxygen bond between these two to make the product. So this, step 2, is just an SN2 reaction. Nothing new there. Technically, it's not bimolecular, so the 2 is not perfect here, but it's an intramolecular substitution reaction. Again, hopefully these are not looking like a bunch of new reactions. These are reactions that you already knew acid-base chemistry worked. You already knew substitution chemistry worked. So now you're just putting the 2 pieces together. So now we know how to synthesize epoxides.